Okay, so we have this strange integral in front of us. We're not really used to an integral in terms of n. But what that really means is that we can find any integral if this is raised to the power of anything that we want. So for example, if it was 1 plus x to the 5 to the power 6, we're going to end up getting a formula that will help us to get that answer very quickly instead of calculating the whole thing by hand, expanding the bracket 6 times and then doing the integral of each term individually. And this is the formula, but we have to show that this is actually going to work. So let's try it. And actually in the next part, we're going to do it for I3. That means we're going to integrate 1 plus x to the power 5 to the power 3. But before that, let's actually show that this formula is going to work. So the integral in is defined by in is equal to the integral between 0 to 1 of 1 plus x to the power 5 to the power of n dx. By considering the derivative of this thing here, x times 1 plus x to the power 5 to the power n, or otherwise show that 5n plus 1 in is equal to 2 to the power n plus 5n times n minus 1. Okay, this is very interesting. We've never seen this before. So, what is recurrence? Recurrence means you're going to find, it's basically what this formula is right here. We have the nth integral in terms of something plus an n minus 1 integral. It could be n minus 2, it could be n minus 3, but in this case, we have an n minus 1 integral. So how do we do it? So it gives us a clue, right? By considering the derivative of this thing right here. So let's just do that. So the derivative of this using the product rule is going to be, well, the derivative of x is just 1, so I'm just going to have a 1 there. So I'm going to have 1 plus x to the power 5 to the power n plus, and I'm going to have the x outside by itself, and then the derivative of 1 plus x to the power 5 to the power n is going to be n times 5x to the 4 times 1 plus x to the power 5 to the power n minus 1. This is just using the chain rule, right? And this is equal to, well, we have 1 plus x to the power 5 to the power n, so we have 1 plus x to the 5 to the power n plus, and now this is 5 times n times x to the power 5, so 5n x to the power 5, and then I have 1 plus x to the power 5 to the power n minus 1. Okay, so we have this so far. Okay, what can we do? Well, if you look at this, right, look at this term right here. We took the derivative of this and ended up getting this right here. But you see this term right here? If I integrate this with respect to x, I actually end up getting in, because that's what we're looking for, right? So if I integrate this between 0 and 1 with respect to x, and I integrate this, and I integrate this, let's see what happens. So I'm going to integrate everything. I'm going to integrate this, and I'm going to integrate this, and I'm going to integrate this. Between 0 and 1, between 0 and 1, and between 0 and 1. Okay, but now look at this. You're taking the integral of the derivative of something. So what does that give you? That's just going to give you the function, right? By the fundamental theorem of calculus, this is going to cancel out, and you're going to be left with everything that's inside. So I'm actually going to be left with x times 1 plus x to the power 5 to the power n, and I'm going to have to evaluate it between 0 and 1. Because now this is just the function, right? I took the integral between 0 and 1 and then the derivative. That means I'm just going to evaluate the function between 0 and 1. That's on the left hand side. On the right hand side now we have this thing right here, but that's just the integral in, right? That's what we want to get. So I'm just left with in over here. Okay. And now what do we have over here? We have 5n x to the power 5, 1 plus x to the power 5 n minus 1. Okay. I'm going to bring the 5n outside because that's just a constant, right? n is just a constant, 5 is just a constant. So I'm going to have plus 5n. And now inside I'm going to have the integral of x to the power 5, 1 plus x to the power 5 to the power n minus 1 between 0 and 1 with respect to x, of course. Okay, now we're going to do something clever. We can't really work with this because this is very complicated, but what is x to the power 5 equal to? Well, if you want to write it in a clever way, you can write this as 1 plus x to the power 5 minus 1. Right? It's the exact same thing. And now look, 1 plus x to the power 5 and 1 plus x to the power 5. So let's rewrite it like that. So I'm going to have this evaluated between 1 and 0. So let's do that first. So if I have a 1 here, I have 1 times 1 plus 1. So that's 2 to the power n. So I have 2 to the power n minus, and then 0 over here is just going to cancel everything. So I have 0 over here. Okay, so I have 2 to the power n on the left hand side is equal to, now the in just stays as in because we're going to end up getting a formula for in terms of other things. So we're going to leave the in over there. Plus, I'm going to leave the 5n like this. And I'm going to write the integral over here between 0 and 1. Instead of x to the power 5, I'm going to write it like this. So I'm going to write it as 1 plus x to the power 5 brackets minus 1 all times 1 plus x to the power 5 to the power n minus 1 dx. And now look what's happened, right? You're multiplying 1 plus x to the power 5 times 1 plus x to the power 5 n minus 1. So this power 1 and the minus 1 will just cancel out. So I'm going to be left with 2 to the power n is equal to in plus 5n times, now what do I have over here? So I'm going to have big brackets because I'm going to multiply by a lot of things. So multiplying this term right here with this is going to cancel out the n minus 1 and the plus 1. So it's going to be left with n. So I'm going to have the integral between 0 and 1 of 1 plus x to the power 5 to the power n. And then I'm going to subtract the integral, because now I'm going to do minus 1 times this. So I'm going to have minus the integral of 1 plus x to the power 5 to the power n minus 1 dx. Of course, this is dx as well. Okay, and this is between 0 and 1, of course, as well. So now this is what we have inside. Doesn't look that neat, but if you notice, this right here is also in, right? Because look, that is exactly what in is. In is the integral of 1 plus x to the power 5 to the power n. And that is what this is, between 0 and 1. And this right here, if you do it n minus 1, this is exactly what you would get. If you did in minus 1, if you replace the n with an n minus 1, you replace the n with the n minus 1 over here. And that's exactly what you have over here. So we've basically done the main part of this question. So now we just have to rearrange how we want it, right? So I have 2 to the power n is equal to in plus 5n. And now what do I have inside here? I have in minus, I have in minus 1. Okay, so far so good. Now we just rearrange in the form that the question asked us. So like this right here. So we almost have it there. So I have 2 to the power n here, and that's equal to in plus 5n times in minus 5n times in minus 1. Okay, I'm going to bring this to the other side. So now I'm left with 2 to the power n plus 5n of in minus 1 is equal to, and now I can factorize this, right? I have in as the common factor, and then I have 5n plus 1. And that's it. That's exactly what I wanted to do. I wanted to show that 5n plus 1 times in is equal to 2 to the power n plus 5n times in minus 1. And that's exactly what we got. And now we can see why it's going to be so useful, because now I'm going to find the exact value of I3. So I3 means you're finding the integral between 0 and 1 of 1 plus x to the power 5 cubed dx. Okay, we want to find this integral right here. So instead of writing it all out and then doing each term by term, integrating each term by term, and then evaluating it, instead of doing all of that, we can just use our recurrence formula that we found out, right? So if I put a 3 in for n over here, what am I going to get? I'm going to get 5 times 3 is 15, plus 1, 16 of I3. So we need I3, but the formula will only give us 16 I3 so far, but that doesn't matter because we can just divide by 16. So I have 16 I3 is equal to, okay, what do I have here? I have 2 to the power 3, so that's 8. So I have 8 plus, and now I have 5 times n, so that's 5 times 3, and then I have I3 minus 1, which is 2. So I'm going to have 15 of I2. Okay, so far so good, but we don't know what I2 is, right? Well, we can use the recurrence formula again. Because if I put a 2 in here now, I'm going to get I2, I'm going to get 10 plus 1, 11. I'm going to get 11 I2. So I have 11 I2 is equal to, and then I have 2 to the power 2 is 4, plus 2 times 5 is 10, I1. So I'm going to have 11 I2 is equal to 4 plus 10 I1. Now I1 is easy to do, right? I1 is very easy to do because that's just integral of 1 plus x to the power 5 between 0 and 1. So I1 is equal to the integral between 0 and 1 of 1 plus x to the power 5 with respect to x. That's very easy. That's just x plus x to the power 6 over 6. And then evaluated between 0 and 1. And what we end up getting? We end up getting 1 plus 1 over 6, which is equal to 7 over 6. And that's I1. Okay, so now we have I2 in terms of I1, and we have I1 as 7 over 6. So I2 is equal to 4 plus 10 times 7 over 6 divided by 11. That's I2, right? We can simplify this, so this becomes 4 plus 70 over 6. We can simplify that more. So if I divide by 2, I have 4 plus 35 over 3 divided by 11. Okay? You can simplify this more if you want, but I'm just going to leave it like that because the whole point is to understand why this is useful and how you do it, not to get the actual answer. So we have that as I2, but now we need I3, right? That was the whole goal. So I3 is equal to 8 plus 15 of I2. So 15 times all of this. So 15 times 4 plus 35 over 3 over 11. And then I'm going to have to divide by 16. Divide all of that by 16. And that's going to be our final answer. So whatever this is, whatever this number is, you can just simplify this right here. This is all the simple fraction stuff you can put in your calculator. And we end up getting some number over here. So I'm going to have some a over b. And that's going to be our answer for I3. So you can see, instead of expanding 1 plus x to the power 5, finding all those big integrals and then evaluating between 0 and 1, all we can do is we can use the recurrence formula and we can end up getting a simple answer. Now, this is only I3, but imagine we had like I7, right? Who wants to like expand 7 brackets out and multiply by each other? That's going to take so much time. But instead, this formula right here, guaranteed, yeah, it takes a lot of time as well, but it doesn't take nearly as much time as like multiplying this out 7 times. Of course, this is an exam question, so it's not going to ask you to do I7. But it just wants to show you that, okay, this is how you practice getting an actual answer, and this is how you show that this recurrence formula works. So they really helped us by giving us a clue right here, but even if they didn't, if you took the derivative of this first and then did some thinking, we'd be able to get the answer ourselves. So yeah, hope you enjoyed the video. This is a different type of method of getting integrals. It's like very special integrals. And yeah, I hope it made sense. If it didn't, let me know how else I could explain it to you, what you need help with. And yeah, let me know what else you want to see in future videos. Like, share, comment, subscribe, and yeah, hope you enjoyed the video. Thanks for watching.